All right, here is 10.2. This is hypothesis testing for a population proportion. So we're going to look at two examples here, and there's a new formula in here called a test statistic. It's similar to the things that you've seen already, so I'm just going to show it as I go through this process. And for this first example, I'll write down steps 1 through 4 or 5, however many there are, and that way you have the listed out steps also. So let's read. When asked, what do you think is more important, to protect the right of Americans to own guns or to control gun ownership? 46% of all Americans said protecting the right to own guns is more important. The Pew Research Center surveyed 1,267 randomly selected Americans with at least a bachelor's degree and found that 559 believe protecting the right to own guns is more important. Does this result suggest a proportion of Americans with at least a bachelor's degree feel differently than the general population when it comes to gun control? Use alpha equal 0.1 level of significance. So alpha equal 0.1 of level of significance, that's going back to what we learned in chapter 9. So all of this is going to start tying in together now. All right, so step 1, we want to check n times p times 1 minus p is greater than or equal to 10. Okay, so checking that's pretty easy. We just need to know what these numbers are. N is how many randomly selected Americans there were. There's 12, 6, 7. P is the percentage that they're giving us, 46%, so 0.46. And that's what we plug in here, and we just compute. So 12, 6, 7 times P, which is 0.46, times 1 minus P, and you multiply that together, and you get 314.7, which it is greater than 10. So yes, check mark. We're good. So now move on to the next step, step 2. Determine null and alternative hypothesis. I'm going to abbreviate hypothesis there. All right, so just by reading this, we can tell if it's a one-tailed or a two-tailed. And so let's figure that out now. So it says, does this result suggest a proportion of Americans with at least a bachelor's degree feel differently? So differently means less than or greater than. So this is a two-tailed test. So two-tailed test, because the words feel differently. Meaning it can be more or less. So if you need extra help, pause the video and try to do H0 and H1 yourself. Alright, so H0 here we'll label as P, and that's 0.46. That's the unchanged, unaffected. And H1, we are trying to see if they feel differently than the general American population, which is not equal to 0.46. Two-tailed means 0.46. All right, that's step 2. Step 1 now, or excuse me, step 3. Determine level of significance. Alright, yes, it tells you the level of significance up here, but alpha equal 0.1, we still need to determine what our z alpha or z alpha over 2 is. So here We're using Z alpha over 2 because it's a two-tailed. We use Z alpha over 2 here because it's two-tailed. If it was one-tailed, meaning left-tailed or right-tailed, we would only use, we'd only find Z alpha. So we'll look at one of those here in a little bit. All right, so let's write down the things that we know. We know alpha is 0.1, so that means we're looking at a 90%. And we want to find Z alpha over 2. And we've went over this several times. Please go back and watch the other videos of finding Z alpha over 2 if you're still not comfortable with it. That is 1.645. All right, and what's helpful at this point is, and it's plus or minus here actually for this one, since it's two-tailed, we care about the plus and the minus. What's helpful here is to go ahead and draw a graph. Draw our normal curve and plot our critical values here. So this is negative 1.645, and here is the positive 1.645. And the critical regions are out here in the tails. All right. So what we want to do now, that's it for step 3. Now in step 4 is the new formula, but it's really something you've somewhat seen before. We want to find a test statistic, and we want to see where it lies on this graph using the information that we were given up here. So step 4, compute the test statistic, and it's labeled as Z naught here. So instead of having Z or whatever we've been used to, here when we have a test statistic, we're naming it Z naught, so that way we can see where it lies on our graph. And if when we calculate it, if it lies in our critical regions, that means we reject the null. If it lies in the middle, that means we do not reject the null. So let's get looking at the formula here first. So Z naught is equal to, and here you may just want to watch, this is a little different than what you've seen, but it's very similar. So here it's P hat minus P naught, and then down here, again, watch me first, you have a big square root, it's P naught minus 1 times P naught, all divided by n, and all of that's under the square root. So it's a big formula, but it's pretty similar to what we've done in the past. So what we need to do now is determine what P hat and what P naught are here. And so P hat is the population proportion of the sample. So remember, make sure you're comfortable with P hat, X bar, and all of those things. Okay, P hat is the sample proportion here. So in the problem it tells us 559 believe protecting the right to own guns, and 1,267 were selected. So remember, this is X over N. N is 1,267, that's the total sample size, and X is the number that we're looking for with that characteristic. So it's 559. Compute that and you get 441. And then P naught is simply the 0.46, what we're given up here in the problem. So you plug all of this into Z naught. So I'll plug that in real quick just so you can see it one time. So you get 0.441 minus 0.46, all divided by this thing down on the bottom. So P naught is 0.46 times 1 minus 0.46, and that's divided by N, which is 1,267, and that equals negative 1.36. All right, so that gets us to step 5 now. Step 5, compare the critical values to the test statistic. All right, and up here in step 3, let's say determine the level of significance and the critical values, because that's really what we did. This is the critical value here, and these are the two critical values. So that's what we did in step 3. All right, so now we want to compare those. So let's come back up here to our graph, and we want to see where this test statistic that we just computed, Z0 of negative 1.36, we want to see where it lies on this graph. So here is negative 1.645, so that means negative 1.36 lies right there. This is Z0 equals negative 1.36. Since it lies inside of our two critical values, in other words, it's not in our critical regions over here, that would lead us to not reject the null. So let's write that over here in step 5 as our answer. Since Z0 is equal to negative 1.36 and the critical values are plus and minus 1.645, Z0 lies within the critical values, we do not reject the null. So it's important to note here, because I've been using the word do not reject and reject. So when we say not rejecting is different than accepting. All right, if we accept it, then we are very confident that it would be true. But here we're saying we're not rejecting it because there's evidence to support H0. If there was no evidence, then we would just reject it outright. All right, let's look at another example here on the back, and I encourage you to try to do this one yourself. Follow those same steps and come back when you're done. But please try to do it yourself. And if you need to watch one step at a time and then pause the video, do that. All right, two major college entrance exams that are a majority of college. Let's start over. The two major college entrance exams that a majority of colleges accept for admission are the SAT and ACT. ACT looked at historical records and established 22 as the minimum ACT math score for a student to be considered prepared for college mathematics. Note, being prepared means that 75% probability of successfully completing college in completing college algebra in college. An official with the Illinois State Department of Education wonders whether less than half of the students in her state are prepared for college algebra. She obtains a simple random sample of 500 students who have taken the ACT and finds that 219 are prepared for college mathematics. That is, they scored at least 22 on the ACT math test. Does this represent a significant evidence that less than half of Illinois students are prepared for college mathematics upon graduation from high school? Use an alpha of 0.05 level of significance. All right, so step 1, I'm not going to rewrite the verbiage here. It's on the other side. I'll label it step 1 and so on as we go. All right, step 1, we need to check n times p times 1 minus p is greater than or equal to 10. All right, when you do that, you'll end up getting 125. So I'm not going to go through the math here just to save a little time, but that is true. Step 2, we want to determine the null and alternative hypothesis. All right, again, pause the video if you need to. So we need to determine if we have a two-tailed or a one-tailed test. So in here it says the Department of Education wonders whether less than half of the students are prepared for college algebra. So that tells you it's a one-tailed test. Because the word's less than. And that means it will be a left-tailed. You could have went ahead and wrote left-tailed in the beginning instead of one-tailed. Either way is fine with me. So we need to determine H naught, and we'll just keep labeling as P. And P is the unchanged, unaffected parameter that we're looking at. It was half. So we want to see if P is equal to 0.5. The null is always going to be equal to. The alternative is where we are testing a different hypothesis. She wants to know if less. So we want to know the probability, the proportion that's less or less than 0.5. All right. Step 3. Step 3 is determining the level of significance and the critical values if there are multiple. When you're dealing with a one-tailed test, you're only going to have one critical value. All right, so here it's telling us that alpha is equal to, tells us in the problem, 0.05, which means we're dealing with 95%. And here, since it's one-tailed, we only use Z alpha. Remember, two-tailed test, it's Z alpha over 2, because we're dealing with two tails. If it's one-tailed test, left or right, it's only Z alpha. And so Z alpha, and then that's equal to Z of 0.05. And I'm not going to go into how to find that. That's in different videos. 1.645. Okay, so here, when we're dealing with left-tailed, we have to be careful. We have to make sure to account for the minus because we're looking at less than. So we want to make sure it's the negative version of this. Remember, when we're dealing with alpha over 2, it can be plus or the minus. The minus is on the left side, the plus is on the right side. So when it's left-tailed, we want the minus one. And that will make a little more sense, and I always draw a graph. It's always very helpful. And it will make a little more sense when we draw a graph here. So we want to plot this, and we're wanting less than. So we know we're on this side of the graph where all the z values are negative. This is 0 here. These are the positive z values and the negative z values. So we're looking here at negative 1.645. So again, when you're dealing with z alpha over 2, that means it's a two-tailed test, and you need the plus and the minus critical value. When you're dealing with z alpha, you only need the plus or the minus, not both of them. And the way you determine that is if you're dealing with a less than problem or a greater than problem. Here we're dealing with a less than, so we want the negative z-score. And this is our critical region here. So what happens is, when we find our test statistic in step 4, if it lies within our critical region, that means we reject the null hypothesis. If it doesn't lie in the critical region, that means we reject the null. We do not reject the null, excuse me. So step 4, let's do our test statistic, and I'll write it again, but I'm not going to actually, well, I will work out part of it just like last time. All right, so that's our test statistic. And from here, we need to be able to find p hat and p naught. P naught's the easy one. That's the one that's given to us in the problem. That's what our hypothesis is testing up here in the null. So that is 0.5. Just think of naught and naught. Those are the same. That's what we're going to use as our p naught. P hat, remember, is the proportion that we're given during the sample, which is x over n. So here, the n is the total sample size, which is 500. And x, with the characteristic we're looking for, is 219, which is 0.438. All right, plug all this in. I'll plug it in just real quick for us. Oh, n is 500. So there's your test statistic, and you get negative 2.17. All right. So step 5. I want you to pause the video now, and I want you to finish this, please. When you're done, come back. All right. I'm going to go ahead and get started. So we found our test statistic of negative 2.17. And now this is our z naught. We want to see where z naught lies on our graph that we drew up here in step 3. So negative 2.17 lies out here. So this is our z naught, which is negative 2.17. That is within our critical region. So if our test statistic z naught lies within the critical region, that would lead us to reject the null. So down here in step 5, since z naught equals negative 2.17 is within the critical region, we reject the null. All right, these are some good problems here. Please review 1 and 2 tailed test, review null and alternative hypothesis, and review how to do all this stuff, and I'll post a couple more videos on this. That's it for now.